Hello everyone, let us read out the question for the next numerical. The question says the RMS antenna current of an AM transmitter increases by 15% over the unmodulated value when sinusoidal modulating signal is applied. Determine the modulation index. Let us try to understand this question. We are given that RMS antenna current of an AM transmitter increases by 15% over unmodulated value when sinusoidal modulating signal is applied. So now if I consider any AM transmitter, we know that there are two inputs to the transmitter. One is carrier and one is modulating signal. So this is my transmitter and this is my output. Now the question says when there is no modulating signal applied, in that case the output current, let us assume, is IC, because when there is no modulating signal applied, then the only input to the transmitter is the carrier signal, so output will be IC. But when the modulating signal is applied, now my output will be the modulated waveform, which will be combination of carrier as well as modulating signal. Let me call it total current IT. So IT is the current amplitude that we get when modulating signal is applied. So the question says the RMS antenna current, that means IC, it increases by 15% when sinusoidal modulating signal is applied. So when modulating signal was not applied, the output current is IC, which is same as the carrier current. When modulating signal is applied, the output current becomes IT, and the question says IT increases by 15%. This simply means that IT will become IC plus 15% of IC. Increases by 15% means the original value will get added with 15% of the original value IC. So this will be nothing but IC plus 15 by 100 into IC, and therefore the total RMS current becomes IT equal to 1.5 times IC. Please note that this whole discussion is for RMS value, so we have to consider suffix RMS everywhere. So with that, my final expression is IT RMS is 1.5 times IC RMS. Now we have to find out modulation index. If you remember, we had derived one very important expression between total current and the carrier current. It is that IT is equal to IC into 1 plus m squared by 2. But this was for the peak values. IT and IC are peak values. If I want to convert them into RMS values, we all know that the RMS value, so IT RMS is equal to the peak value IT divided by root 2. That means IT is equal to root 2 into IT RMS. And similarly IC, that means carrier current, and its RMS value will be nothing but peak value of IC divided by root 2. That means IC will be equal to root 2 times IC RMS. So if I replace for IT and IC in terms of their peak values, you can see it will be IT RMS equal to, this root 2 will cancel out from both the side. We will have exactly same expression that was in terms of the peak values, now available in terms of RMS values. So let's now make the substitution. IT RMS is given to be 1.5 times IC RMS. So IT RMS is 1.5 times IC RMS, and this is equal to IC RMS into under root 1 plus m square by 2. IC RMS will cancel out from both the sides. Therefore 1.5 is equal to under root 1 plus m square by 2. If I square on both the sides, it's 1 plus m square by 2 is equal to 1.5 square, and therefore solving this equation I can find the value of m will come out to be 0.8. Now if in the question, if they had not mentioned anything about RMS values, then we would have simply assumed them to be the peak values and gone ahead. You can see whether you consider RMS values or peak values, that common factor of root 2 cancels out and exact same formula is used in both the cases.